it. All right, so you may not have picked the same top and bottom, but I picked the small one to be the top, or the big one to be the top, and I picked the small one to be the bottom. So my scale factor was 36 to 27, which was 4 over 3, which means I had 28 over Wn, which equals 4 over 3. Then my cross multiplication, what have you, and we come up with 4. Wn equals 84, divide by 4, and you come up with 21. The angle should be the easy one, because as long as they're similar, their angles must be congruent to their corresponding angle. So if we look at angle W, W corresponds to angle C, so they should both be 28 degrees. No scale factor required. Don't use your scale factor with angles, okay? Similar shapes have congruent angles. It is kind of that worst mistake I see on tests because it's supposed to be like an easy point. It should be, can you see that they're corresponding and that they're congruent? That's all I'm asking for. No real math behind it. All right, questions on the homework? Labib. 22.
Find the ratio of the
Mm-hmm.
ratio scale, and I don't know why that is.
It's the same thing as the scale factor.
Yeah, that's what's fun, yeah. How come
Well, we did that yesterday in the notes. So if you look at on page 184, right at the top it says, if two polygons are similar, then their perimeters are proportional to the scale factor.
Yeah.
Okay? And that actually goes back to the rule that we have on page 179. On page 179 it says, if you have A over B equals C over D equals E over F, and you add all your top things, so that would be all your sides, added to all your corresponding sides, it equals that smallest fraction, which would be your scale factor. Good?
Yeah.
Okay. Make sure you maybe highlight that in your notes so you know not to forget that for a test. Yeah, Asher. 34. Get this guy going. 34, that box problem. All right. So 34 says the card shown was cut into 4 congruent pieces, with each piece being similar to the original shape. So that means if I highlight something really quick, if I highlight any one of these cards, like this card, it says that card is similar to the entire shape. So what I did is I drew one card. One card is X by 10 units. I just flipped it on its side, said, well, that's X by 10 units. It has to be similar to the big stack, which is X to 10 plus 10 plus 10 plus 10 is 40. So it's similar to the entire stack, so I put them at the same, I rotated it to show that they're the same. So the corresponding parts are X and 40 and 10 and X on the big one. So then you just have to pick one to be the top and one to be the bottom. I picked the small one to be our top of all our fractions. And I picked the other one to be the bottom. Well, there's no real scale factor because I can do the top is X over 40 is one ratio. But it has to equal the ratio of the other sides, which would be 10 over X. Which then we could use our cross multiplication or means extremes property, come up with X squared equals 400. So X either equals a positive or a negative 20. It can't be negative, so it has to be a positive 20. So not every time when we have similar shapes are you going to immediately know a scale factor. Sometimes you just have to plug two sides in and see what you get from there. Does that make more sense? Okay, cool. Other questions? Questions going once? Twice? 3 times? Do you have a question? No? Not 13? Okay. Did we have a 13? Didn't even have a 13. All right. All right. Let's go to today's lesson. And yes, there is proofs. There is one proof. And it is right there. And you won't have to repeat a proof on the test. There are no proofs on this test. All right. For anyone that likes proofs, I apologize. There aren't any proofs on this test. There will be proofs on the exam. So you can look forward to those. This proof is really just a concept of idea. What you're going to be doing on several of these problems to prove that two triangles are in fact similar. So we do have a postulate. It says that two triangles are similar if and only if they have two pairs of corresponding angles that are congruent. That's big difference than yesterday, because yesterday said if you have a polygon, you have to prove that all the angles have a corresponding congruent angle, and you had to show that all sides were proportional to each other. This is saying if you have two triangles, you just have to show that two angles are congruent between those two triangles, and you have similar triangles. You don't have to look at the sides. All right? So all we have to do is show that two angles are congruent between the two triangles, and you can automatically start working on it as if it's similar, because they are, in fact, similar. So what we're going to be doing on a lot of these problems is what's actually here. We'll be given maybe an angle or no angles, and we actually have to show that we have two angles that are congruent. So in this case, we were given that angle B is congruent to angle E. And just a reminder, our given is usually our first step, so that's always how we get our point. In order to show that these two things are similar, I need another angle being congruent between those two triangles. What other angle is there that shows that those two triangles would be similar? Yes? Yeah. We can say angle FIB is congruent to LIE. And what lets us say that? Yeah. Vertical angles theorem.
Do you have to write theorem after it or no?
I am. But you can just put vertical angles. Yes. All right. And now we could say that triangle fib is similar to triangle lie. And that is because of this angle postulate. We'll just put angle postulate. Once again, you will not be proving these, but you are kind of in your head. You're showing that they're similar by coming up with two angles that are congruent. So that's what those first two problems say. They say to determine whether the triangles are similar. If so, write a similarity statement and explain your reasoning. We're not really going to explain our reasoning. We're just going to write that similarity statement. We're going to talk through our reasoning. All right, the first thing is there's two triangles there. There's a small triangle and a big triangle. In this case, you don't always have to draw it. When we get to more complex one, you should really draw both of your triangles, or all three of your triangles, as it were. So I'm going to draw my big triangle and my small triangle down below. So we have a big triangle, and that would be ADC. And then I'm going to draw my little triangle, which is going to be AEB. If we look here, we have 52 degrees as C and 52 degrees as ABE. So that means those two angles are congruent to each other. So I can put those on the newly drawn triangles, that C is congruent to B. Now I need one more angle being congruent. What is the other angle and why, Sangha?
Angle A, because they're sharing angles together.
because they're sharing angles, which is the the Wolf theorem. The what, Labib?
Oh.
Not reflexive. Reflexive. I had too much. It is going to be the reflexive property that says A is congruent to A. Boom, boom. So we could use the reflexive property. You could have also recognized that, well, if this is 52 and this is 52, these lines are parallel. So angle AEB would be congruent to EDC because they are also corresponding angles. But you just have to prove one. And for my money, I always look for reflexive because they just share it. You can see that they're the same thing. You don't think about other properties then. But either one of those would have been fine. So because we use that reflexive property, we can now say that triangle ADC is similar to triangle ABE. We're all okay with that? So I can just move on?
No.
So everyone's okay with that? Everyone's good? So we move on, Tori? A should be A, E, B. Order definitely matters. A has to correspond to A, which it does. E has to correspond to D, which now it does. And B has to correspond to C, which it now does. All right, so I'm going to name an angle that is congruent between those two triangles in the next one. So I have triangle SVR and I have triangle UVT. Yeah.
SVR and TVD.
SVR, which is right here, and TV. U, right?
Mm-hmm.
Why?
Vertical
Vertical
angle.
angles. Cool one. Can someone name another one? Yeah.
SRV and VTU.
And VTU. Why?
Because they're alternate angles.
They're alternate interior angles. Yep, they're alternate interior angles. But you could say the same thing about angle S and angle U as well. But you just have to show two of them. Don't go to the full lengths of getting all three of them. We already have two of them are congruent. So by that angle postulate, we can then say that triangle VR, that's a B, VRS is similar to triangle VTU. Correct or incorrect?
Right.
Ooh. Whew. Good thing I didn't mess up both of them. That'd be really embarrassing. Oof, indeed. All right, this one says solve for A and B. This might be another time where you draw both of your triangles, or if you're good at them, you can just look at. I like drawing the two triangles so I don't make a mistake. I like drawing my two triangles and making sure I don't make a mistake. Right, Davion?
Yeah.
Yep. All right, so my two triangles here. I'm going to have a really big triangle. So what I'm doing is I'm copying this really big one, and I'm going to put it right down below. Yeah. Yeah. And then we'll do that small triangle. So those are my two triangles. Now I'm going to put the facts that go with it. So that big red triangle has a 48 on one side. It has a 40 plus 32, so that's going to be 72 on the top. And on the bottom angle, we have A plus 40. I can't reduce it to any more than A plus 40. On this small triangle, we have B here. Then the top was 32. And then the long arm of the law was 40 units. Oh, before I do anything else, I should probably make sure that they're similar, huh? In case I'm on a test and one isn't similar, and then you didn't have to do anything at all, you just say it's not similar. So let's check to see if this is similar. Could someone name one angle that is the same in both of them? And it's going to be kind of hard to tell me, so just give me an idea. Yeah.
The angle in between 48 and A, and the angle in between B and 40.
So you're talking about, let me see if I got that one right. This one?
Yeah, those two.
And then what's another one we can get? Songa.
Between 48 and 40 and B and
between B and 32?
And 48 and 40.
48 and 40. So this one here
Yeah.
and this one here.
Yeah.
And what let us do both of those? Yeah, they're both corresponding. We're going to give you another angle too?
Oh, you could do the one between 30 and 40.
Yeah, I could do the one that's in between this 32 and 40 because they're reflexive property, right? Whatever you see first, use that. I see parallel lines, and I'm probably going to say corresponding, because it's real quick once I have to use a parallel line. All right, so we know for a fact that these are, in fact, two congruent triangles. So that means there's a scale factor between the two of them. Can someone tell me the scale factor between these two similar triangles? What is the scale factor between these two triangles? You don't have to simplify it, just give me that number. Yeah.
Let's see, 32 to 72.
32 to 72. Did you also have that simplified?
Yeah, 4
What?
to 9.
4 to 9. All right, that means you took your 32 from that small triangle, right? So that small triangle is going to be your top of any fraction that you use, which should mean the big one is the bottom of any fraction we use. Well, I'm always going to pick the easy one to do first. I see that B corresponds to that 48. So let's solve that first because that we can just do right away. So we have our scale. So we're going to say B over 48 is going to equal 4 over 9. Well, working that through, we can use our means extremes or our cross multiplication, however you call it. We'd end up with 9B equals 4 times 48. Well, 4 times 50 is 200. Minus 8 would be 192. We looking good? What does our B equal then? What does our B equal? We just have to do 192 divided by 9. There should be more than one hand up. You can even use your calculators. John? 21 and a third? Yeah. So it doesn't work out super nice. That might be why we didn't have so many hands up. So we can put 21 and a third, or we can just, I know I just reduced the fraction. Yes, I just reduced the fraction. So I said this equals 192 over 9. Nothing nice. So you can either have what John had, or you can just put 64 over 3. You do not have to put it as a mixed number or a decimal if you don't want, if it's that small of a fraction. All right, cool. That's B. A, you can't go directly there. Well, you can, but you have to push through, guys. On the test, I can't tell you how many people just stopped here because they're like, well, I don't know what A actually is for the side. Well, we know what A plus 40 is. We know what A plus 40 is. So let me circle that. A plus 40 corresponds to 40. So just write it. Write everything out and see if it works. If it doesn't, come up with another plan. Well, in this case, we have A plus 40 corresponds to 40, and that has to equal my scale factor of 4 over 9. Well, using our means extremes or cross multiplication, we're going to end up with 9 times A plus 40. Does anyone see any mistakes yet? People just keep letting me go?
No.
There's a big mistake.
Yeah.
What's my big mistake?
A is supposed to be on the bottom.
Yeah.
I was just looking.
Okay, that's fine. As long as someone figured out. I didn't want to have to get through the whole thing. It should have been 40 over A plus 40 because the top one was my 40. The bottom one was my A plus 40. That's why if you're using fractions, you better label which is your top and bottom because you're going to do this several times and you'll forget eventually. All right, so we actually are going to have now 9, let's do the 4 times A plus 40 is going to equal 360. Here's kind of a nice thing. You could distribute that 4, or in this step right here, we could divide both sides by 4. Thanks, Sonia. So we can divide both sides by 4 just to kind of simplify our life. And we'd come up with A plus 40 equals 90. Subtract 40 on both sides, and you come up with A equals 50. There's my A, there's my B. I am done. Do not quit on these problems. Find a side, find what it corresponds to, put it down, And either you can solve it or you can't, but you'll get more points for doing that than just saying, I don't know exactly what to do next, so I'm not going to try anything, Mr. Pavian, on the test. Try something. Try something. All right, the most complicated problem we're going to do is the next one. And hopefully no one got too far ahead. Because there's an easy way to do this and a really hard way to do this. There are 3 triangles on there. And all 3 of those triangles are similar. So let's start with this really big triangle. We're going to copy that really big triangle down below. So I'm looking at that big triangle that I have in red right there. And we're going to copy that down below. All right, that's that big triangle. Oh, let's make my eraser bigger. Oh, that's so much better. All right, the next thing I'm going to look at is the fact that 90 degrees, maybe I should leave it in red, is at the top. Maybe you didn't put it at the top, maybe you put it at the bottom, but wherever you put it, you should try putting all of your triangles to look exactly like that one. So the next triangle I'm going to look at is that little guy on the left. This little guy right here, I don't know if that blue shows up, but that little guy right there, that's 21, E, and C. When I rewrite this, I'm going to actually change that color to purple so it shows up a little better. I'm going to note where that 90 degree symbol is. The 90 degree symbol is right here. I want to flip this triangle when I rewrite it so that the 90 degrees are on the same spot. Yeah?
So we know they're all similar.
We can actually prove it.
Okay.
See how this is 90 degrees here? This has 90 degrees.
They only need one.
And they have a reflexive. They're going to share this angle between both the big and the small one.
Oh, so we're not doing all 3 of them.
We are going to write all 3 of them.
But not all 3 of them are similar.
Well, they'll all be similar to the big one.
But by different means.
By different means, yes.
Okay.
So this little triangle is going to be similar to the big triangle because they do share this angle right here and the 90 degrees. So maybe I'll put that down. So because they share this angle here and the 90 degrees, that those 2 shapes are similar. So I'm going to copy that purple one down, but I'm going to copy it in such a way that the 90 degrees is in the exact same place as the 90 degrees was on the other one. That means I have to really think about how I'm going to label this. I need to label this with 21 on the hypotenuse. C is on the left-hand side, and E is the longer side. I'm going to go ahead and label my big one, too. I forgot to do that. That is 75, 72, and 21. All right, so both of these triangles are similar. All right, then let's do that medium-sized one. That medium-sized guy, maybe we'll make it green. The medium guy is this one here. This one is also similar to the big triangle. It is similar to the big triangle because we have 90 degrees here, and they would share the little tip there by the reflexive property. So those 2 triangles are similar to that. The green one and the big one are going to be similar. So let's draw that green one down here. Let's label our sides. So first of all, the 90 degree I put in the same exact spot. And the hypotenuse was 72. The long side was D. The short side was E. So what Emma brought up was really important. I'll kind of do it sideways. The big triangle is similar to this triangle. The big triangle is similar to that triangle. There might be a way to prove that this one is similar to that one, but we don't need that fact. All right, we're just going to go with the big one is similar to that one, and this one is similar to that one. So depending on what letters we're looking for is going to depend on what triangles I'm going to use. So I'm going to go ahead and number these. 1, 2, and 3. So I know what I'm talking about when I'm doing this off to the side. All right, so I have 3 triangles. Both the smaller triangles are similar to the bigger triangle. Someone name a letter you want to solve. Whew. One more time, everyone.
C.
All right, and all together, loudest one wins. Go.
C.
Ooh, C was quick and first. So we're gonna go with C. All right, we're gonna solve for C first. Probably because she cheated a little bit. I was like, the loudest one, C! So we're gonna solve for C. We're gonna solve for C. So we have to pick the specific triangles that I can actually use to solve for C. That means I'm gonna use triangle 2 and triangle 1, because this is the only one that has C in it. So to solve for C, I need to use triangle 1 and triangle 2. Which means I need to come up with a scale factor. As long as I'm dealing with 1 and 2, I can use the same scale factor. So the scale factor from 2 and 1 is going to be that 21 over 75. Can I simplify 21 over 75? It's not terribly important you do, but can you?
7 over 25.
It would be 7 over 25. Because 3 goes into both of them. Now, it's not a huge deal. These are going to be big numbers you need your calculator for anyway. All right, and if you didn't simplify, life would be okay. All right, so our scale factor is 7 over 25. So I'm looking for C. If I did 21 over 75, that means my purple one has to be the top, and my red triangle has to be on the bottom. So if I'm looking for C, I'm going to put C over 21. I'm going to put C over 21 equals 7 over 25. Which if I'll make sure all my numbers are right, yes. So if we work this down, we're going to end up with 25C equals 147. Which if I do that division, I'm going to use decimals on this one. I'll have C equals 5.88. And you might say, Mr. Papian, how do I know to use decimals or not? Leave it in fractions unless I tell you otherwise. And usually the directions will say round to the nearest tenth or something like that. In this case, I'd be happy with fractions or the decimals because it's not repeating. And I don't like 147 or over 25. It's a big fraction. The bigger the numbers are, the more likely you're going to use a decimal. Now, using 1 and 2, could we solve for another side?
Yeah.
What side could we solve for, Sam?
Let's see, so if I go
E. Why not use the exact same triangle, because I can use the same scale factor. Rather than going to another triangle to find E, I'm going to use this triangle to find E. So that's going to be E over 72 is going to equal 7 over 25, which is then going to give me 25E equals 504, which is going to be about 20.16. I'm out of letters for number 2, so that means I need to move on to triangle number 3. I already found E. If I'd solve E by comparing it to these two triangles, it'd be the exact same thing, so why solve it twice? So the only thing I need to do is find D. To solve D, we have to use triangle 1 and triangle 3. Since I'm using a brand new triangle, I need a new scale factor. You can't use that same scale factor. So the scale of this one, let's do 3 to 1. That'll be 72 over 75. That can also be simplified to 9 over 25. Wait, no. No, 24. I was thinking of a different problem. I was trying to do it off of memory and not actually doing the math. Dumb. Okay. So we have 24 over 25. And we know that I picked the green one to be on the bottom. So we're looking for D. So let's do D over 72 is going to equal 24 over 25. Which is then going to be 25D equals 24 times 72. 24 times 72 is 1,728. That's a huge fraction. That's usually when you do a decimal. And that's going to be about 69.12. So D equals 69.12. And we found all of our letters. Yes?
Could you subtract C from 75?
Could you subtract C from 75? Oh, yeah. Yep. Because C plus D equals 75, that'd probably be the easier way, but I like using all the triangles in class. But absolutely, since C plus D equals 75, you could just do 75 minus C, which should give you your D if you did everything correct. Yep. All right, questions on that? I promise you, people that rewrite these triangles get these right a lot more than people that try to visually check 3 triangles and where the parts go. It's just much easier to see where everything corresponds. All right, the last thing we're going to do is a little word problem. We have a tree, and it's casting an 18.5 meter shadow. Then we have a mailbox that's casting a 2.4 meter shadow. We also know that the mailbox is 1.5 meters high. So a picture of this might look like a really sweet tree.
Wow.
I should do it green, right? Because it's a tree. So we have a really sweet tree. It's gonna. I'll do brown for the base.
Oh. Oh, yeah, that's true.
All right, here's a beautiful tree. Everyone can say how beautiful it is right now. Thank you. And it's casting a shadow. That's its shadow. And then we have a mailbox. Ooh, I'm bad at mailboxes.
Square and then like a line. Stick.
Looks more like a garbage can, but once we do this, it's a mailbox.
Make it blue.
That is casting a shadow. There, now it's blue. That's casting a shadow. All right. That's my mailbox, and it's casting a shadow. I have a tree, and it's casting a shadow. Well, the shadow on the tree is 18.5 meters. The shadow on the mailbox is 2.4 meters. But I also know the height of the mailbox, which is 1.5. Watch what's going to happen here, guys. Everyone's going to freak out. These create 90-degree triangles. And they are, in fact, similar because of the angle of the sun. We have this 90 degrees here, and the angles will be the same because it's coming from the same location. The sun's coming from the same location. Rather than going through all that, just know that they are similar triangles. We don't need to prove it in this one. All right, it says, how tall is the tree? So let's call the tree tall. Call it a T, because it's tree tall. Well, if these are similar triangles, then they have a scale factor of the shadow to the shadow. So we can do 2.4 over 18.5. That's going to be the scale. Well, that means I'm going from mailbox to tree. So the mailbox height was 1.5 to the tree, which we don't know how high it is. But now we have an equation, we can actually solve it. So we're just going to use that cross multiplication, or that means extremes, to rewrite this as 2.4t. Is going to equal 1.5 times 18.5 is going to equal 27.75. And our tree is going to be about 11.7 meters. Now, the word problem didn't say specifically to round to the 10th, so I couldn't take any points off for where you rounded it to. But what is kind of your sign that you should round it to the 10th? What in the problem tells you to round it to the 10th? Yes?
Everything else is in the head.
Everything they give you is in the 10th, so you better stay in the 10th. It's a good advice for like a science class, because I know you need significant figures a lot, and a lot of times they don't tell you, you just have to know from what's given. All right. In your homework, there are word problems. I think I drew the pictures on these for the most part. But if you get stuck, make sure you check the answer key because I redraw the triangles off to the side so you know what triangles to look at and what's being pulled out.